Okay, good evening, everyone, and welcome to our brand new office. So I hope you enjoy the view, this sunset. Welcome to Nutanix. We're very glad to host all of you guys here today, and those joining online. Hello and welcome. My name is Maxim. I'm glad to host you today. I run the specialist solution architecture team for APJ. We're very happy to start this collaboration with KS User Group, or how we call it now, KSUsergroup.AI. It's a very nice name. And we hope that that will be a very fruitful collaboration between Nutanix and this amazing community that we have here today and online as well. Welcome once again. We'll have a very, very good program today. We're starting with Winson and then with Vivian. So if you need anything, just raise your hand. We have our team here to help you. We have some food and drinks and amazing views and a great content. Young Kang?
Yeah. Thanks,
Go ahead.
Maxim. Thank you so much. Yeah, I'm so glad we can collaborate, we can work together. I really would love to visit Singapore, yeah, but I'm a little bit far away and it's in the cold area. Okay. Anyway, I'd love to give a quick introduction of the community. It's been a while. I never been to Singapore, and we do have some exciting updates. On the screen, as you guys can see, our community grows so strong. Okay, if you never been part of our community, please feel free to join any one of the groups. I normally call this our node group or node pools. Okay, so if you scan the QR code, actually, or if you go to the slides, I'm going to share you shortly, or you click the link so you can find all the details. Okay, so right now, can you guys do a guess who is running the largest Kubernetes cluster in the world? Probably it's really hard. Yeah, I don't think anyone can get it correctly. So technically, actually, before that, let me show you these screenshots. So basically, we encourage our members to help us to take photos, to upload the photo, to share the photos, do the LinkedIn post, help us spread the word. If you don't mind, scan the QR code, you can upload the photo, you can download the photo, etc. Now back to the question I have. So who is running the largest cluster in the world? That's KSUG.AI or Cube Smart and AI User Group, okay? So whatever you pronounce this, KSUG or KSUG, I pronounce it as KSUG.AI. So we just got 180,000 nodes. We're running the largest cluster in the world. We got the control plane running across APAC, EMEA, and America. We got 6 of the largest groups. So definitely, if you haven't checked it out, you should check it out, okay? Make sure you scan this QR code. It's very important. We're going to give away some of the really good swags. Thank you everybody for joining us, okay? So I'm going to quickly to show you our landing page. So before that, I want really to give you some idea, why we shifting to using Canva instead of PowerPoint slides, because Canva makes life easier. You can easily share the slides in the read-only mode, and you can allow with Chrome, you can create the QR code. So if you scan the QR code, you can get all the slides. Not just our introduction. Once I get the slides from other speakers, I will share the slides as well. Okay. I hope you got a chance to use your phone to scan the QR code, because it's very important. So this QR code actually it's clickable. Okay, if you click the QR code, it'll take it to the landing page where we share all the learning certification event discount code across our LinkedIn page. and how to become a cube astronaut. I'm feature some of the guys, ladies, they create some awesome videos I put together to help our friends. And from the discount code page, you can find the latest discount code I just received this morning. You can get 40% off across all the all the Linux Foundation learning certification bundle, etc. And then you can join our events. You can join other events like a Cubicle North America. You can get a 20% off. Why not? And if I go back, check the resources page, you can find all the learning resources. Some of these actually completely free, like a KCNA free learning course from Andrew Brown. And you can use the KCSA mock exam. I know most of you guys are also on the way to become a cube astronaut. To get to the blue jacket, you might have noticed I'm wearing the blue jacket, but I covered the CNCF because I'm KSUG.AI, okay? And I make sure you understand Killer Shield. That's one of the best exam simulator. If you do CKA, CKAD, CKS, definitely you need this. And also Killer Coda. Yeah, I'll let you guys to explore by yourself. I'm going to go back to the slides. So as you can see from here, the reason I want to scan the QR code here is you can click the QR code, or if you don't, if you are on your computer joining remotely, click the QR code, you can find the lucky draw form, okay? I need your help to help us to grow the impact, to help more community friends. So that's why I put together all of these, our social platform, and all we ask is your email, your LinkedIn URL, and what swags you like to choose. Okay, most of these are donated by our friends or our sponsors, like a Code Cloud. For those of you who never heard of these, Code Cloud is one of the best learning platform for DevOps, for multi-cloud, for your Terraform, for your platform engineering, etc. And all of these are free, not free, 50% of exam vouchers by our friends. So make sure you follow our LinkedIn pages, join our Discord, and subscribe to our newsletter. And then you are part of our lucky draw. We're going to give away some really nice swags. Let me go back to the slide. So tonight we got some really great topics. So Nutanix, yeah, traditionally I know the company is for the hyper-converged infrastructure, for the virtualization like AHV, etc. But I also just learned they also have the container solutions or Kubernetes. They call NKP, Nutanix Kubernetes Platform. So I believe earlier last year, they acquired a company called D2IQ. That's where they provided the whole Kubernetes offerings. So the first topic tonight, we got Winson So. He is an advisory solution architect from Nutanix. Less marketing, less sales. Let's go straight to the technical part. The multi-cluster management is very important. How you can leverage ClusterAPI and GitOps via the NKP platform. And after that, we go to the second topic from a CNCF Ambassador. She is also our KSUG.AI organizer, Vivian Hu. She is from second state. She will talk about how to be efficiently. He will talk about the topic about efficient and portable AI, LLM inference on the edge cloud. And the last but not least, we don't have the time to do the quiz time. I don't have the questions yet. So if you took the screenshot earlier, you got the link, you fill out the form, we will do the draw from the list of the participants, okay? So before I hand it over to the first speaker, I really want to highlight our mission. Our mission is just to empower the community to learn faster. So I created the community from 3 years ago, actually, or 3 years plus 1 month, okay? That was September 30th, actually. And our mission is to help people to learn faster, to get certified more smarter. You don't want to spend too much money for the certifications, for the learning, for the events. I want everybody to grow stronger. That's why we call ourselves Cube Strongers, okay? So a little bit of other programs also created by our community. The first one is, it is actually the world's first community created program. I call it OS channel or AWS channel. So basically for someone to be fully certified on AWS, they don't have a nice title. We created the title. It's called OS channel, AWS channel. So if you never seen this, you never heard of this, you definitely should check it out. If I click the link, you can see we featured how many people on our map. So we already got 89 people featured on our map. You can filter by the country. Let's say how many from Singapore? Is there anyone from Singapore? Okay, we do have a few. Oh, actually, only one.
I'll continue your workout later.
Sorry, is that question or someone else not on mute? Not mute. Okay, anyway, let's continue. So our community is more about to inspire more people to learn. Continuous learning does help you to find the next exciting job, to be keep stronger, okay? So that's one of our programs. And after we created the first community certification program, we also created the second one, even better, okay, or even harder. So it's called Cube Strong, okay? In order to become a Cube Strong, to be part of our club, you need to be fully certified on AWS plus fully certified on Kubernetes. That's the Cube Strong. We even made another, enhanced program called a Golden Cube Strong. You need to be a Cube Strong, Golden Cube Strong, plus OS channel to become a Golden Cube Strong. Guess what? Globally, we already have how many? Probably about 40 people are part of our Cube Strong club. So I'm not going to show you again. Actually, let me show you again. Click the link. If you click Cube Strong, you can find who are the first Cube Strong club members. So not a lot. We got 39 people. You can filter again. You can filter by the title certification. Cube Strong, that's the elite programmers. We already have 6 part of the Golden Cube Strong Club, okay? Which is different than the Golden Cube Strong. We are better, okay? So come back. So I guess I've done enough talking just to highlight 2 very important things. If you don't want to miss the latest learning certification event discount code we discovered, so make sure you visit our link tree, okay? The link tree is just basically one platform, one location. You can find all of our links, social links. If anyone wants to join us as speakers, as volunteers, you can find all the links here. If anyone wants to do free certifications, like a free AWS certification, free Google certification, or free Oracle, we discover all the certification deals and put together on our link tree. So for our community to consume, it's completely free. We don't charge anyone, okay? So if you want to join us as a volunteer, here is a form towards the bottom, okay? How to join us as a speaker, join us as a sponsor, or you can follow me on LinkedIn. Oh, by the way, I haven't introduced myself. My name is Yongkang He, and I just got 49,000 followers. Yeah, I need more followers, okay? Please click follow. It doesn't cost you any money, okay? Oh, thank you, guys. I think I've done enough. And what else? Yeah, this one I already showed you. You can find all the learning discount from our landing page. And with that, I'd like to highlight two of our sponsors. The first one called Cloud. They made a very they actually from a very beginning they started to support us. They even give our community some special discount. Okay, if you go to their website, you don't get that deep discount for the learning. Okay, try to visit our links we shared. Yeah, actually, this is also clickable. Okay, if I click this, you can see it take you to this web page, your gateway to DevOps and the cloud. So you can find the price here. So you got a 21% off. But do you really need a Pro or AI version, which costs you more? But with this one, 21% off. And I'm going to share you the discount code now. You can get the extra 20% off, which is great. So, and secondly, I'd like to thanks to, Nutanix to give us the nice venue for us to host the meetup events at the Nutanix office. Okay, if you haven't heard Nutanix, make sure you visit their webpage. So they also transformed over the last few years, become a hybrid cloud solution or a vendor. Okay. I think that's all from my side. Yeah, just to highlight, use this discount code, you can bring down the cold cloud standard to just $144. So last but not least, before I hand it over to the first speaker, we got a 3 cold cloud 6 months access to give away. Make sure you fill out the form. We will do the draw and then send you the notification by email. Okay, so you don't have to wait on site. If there is any other swags from Nutanix, feel free to take it. Yeah, thanks, Nutanix. And with that, I'm going to hand it over to the first speaker, which is Winson. Over to you.
Thanks, Yongkang. So, hi everyone. Give me a second. Let me just share my screen. So today I'm going to be sharing, let's go straight into the meat, right? I'm not so much of a marketing guy, not so much of a sales guy. So let's just go straight into the meat, right? So today I'm going to be sharing about simplifying cluster and application lifecycle using ClusterAPI, CAPI for short, cluster class, parent, and GitOps. So my name is Winson, right? I'm a advisory solutions architect. I work at Nutanix. I'm what I call myself a technology dabbler. I spend a lot of my time, a lot of my weekends, just dabbling with technology, right? My friends, they call me like a person without any life. I don't go out and party. I write code and play with Kubernetes clusters. Okay. I recently got my kubestronaut. So I got it in 2 months, early somewhere in May, right? And totally agree with what Yongkang mentioned. Definitely sign up, register, and get all the giveaways for Code Cloud, because that Code Cloud was actually one of the key platforms that I used in order to get my kubestronaut certification. Okay, so I've got my LinkedIn as well as my YouTube channel all posted over there. If you all want, feel free to take a look. I post a lot of content around Kubernetes. Okay, so this is the agenda we're going to be covering today. First one is challenges in the traditional Kubernetes deployments, especially in the enterprise world. Some of the solution overviews, as well as some of the features that we use in order to solve some of the challenges. ClusterAPI, talk about ClusterAPI, cluster class, Karen, as well as applications and fleet management. Right, then we will end off with a demo. So I am notorious for not practicing my slides. I am notorious for not doing recorded demos. I always do them live. So if I screw something up, I hope you all be patient with me. All right? Okay, so some of the key challenges that we see today, right, especially when we're working with many Kubernetes clusters. How many of you manage less than 5 Kubernetes clusters? Less than 5, huh? Not more than 5. How many of you touch less than 5 Kubernetes clusters in your enterprise day-to-day job? So I think all of you manage more than 5 Kubernetes clusters, right? Which is good. This is why, why I hope today's session might be helpful for you all, okay? So traditional infrastructure management approaches, right, has always led to what we think of as configuration sprawls. We might have a Kubernetes cluster or multiple Kubernetes clusters with different configurations, right? And now I have to maintain a repository of all those different configurations in order for me to get my single source of truth. Okay, and this is going to be very difficult to scale as and when you need to add more additional clusters. So some of the enterprise requirements that we see, especially when we're speaking to enterprise organizations who are managing a lot of Kubernetes clusters, is the first one is that they require some form of standardization. They want to have a consistent cluster deployment experience with standard operating model to be deployed across their entire environment. Okay, they require security and governance, right? Because obviously in enterprise, when you run Kubernetes clusters, you require some form of security configuration so that you ensure that whatever runs within the clusters are secure. Okay, we've got operational efficiency because now we want to ensure that when we deploy our clusters with that single consistent deployment framework, we don't have to rewrite our code or rewrite our deployment toolkits, right? So think of it as you might have a Kubernetes cluster running Cilium as a CNI and another Kubernetes cluster that is running Calico as a CNI. We now have to manage two different types of resources in order to reconcile our state of clusters. Okay. And lastly, because we now have a single place to store all our deployment manifests, we will then have the ability to achieve scalability, especially as we deploy more and more clusters. So from a solution overview perspective, right, how do we then implement all of this enterprise requirements, all right? Is it small? Is it big enough? Okay. At the very top, we have got this thing called GitOps. I'm sure this is a very popular word. It has evolved very much through the years. But we need a controller, right, to reconcile the changes within Git. And this is where we use something like GitOps tool like FluxCD, right? And with FluxCD, we can then integrate with toolings like ClusterAPI Core. And what ClusterAPI Core really does is that it provides a unified singular API that allows us to interact with different types of infrastructure. So it could be AWS, it could be Azure, it could be Huawei Cloud, it could be Oracle Cloud Infrastructure. And every single one of them has got their own cluster API providers that allows us to seamlessly integrate with these providers in a Kubernetes native manner. Then we have got cluster class, which allows us to do things like templating, and ClusterAPI provider for Nutanix, which is a Nutanix ClusterAPI provider so that our Kubernetes clusters can start to deploy on top of Nutanix clusters. And we have got this thing called Karen, which is ClusterAPI runtime extensions for Nutanix, which provides some form of intelligence from a ClusterAPI perspective. Okay? So the whole idea is so that you can define all of this once and have it deployed across environments many times. So think of it like rubber stamping Kubernetes clusters. And each time you need to deploy a new Kubernetes cluster, you know that it has already that standard set of configurations that you can use to deploy and scale, right? So some of the features that we achieve with ClusterAPI and GitOps, right, is that we now get declarative infrastructure. And if we do it right, and we do it with that culture in mind, it will allow us to treat Kubernetes clusters as cattle, not pets. If a cluster goes down for whatever reason, we just use GitOps to respin up a new cluster, and everything gets pulled directly from Git. I have a customer, right, who had to tear down Kubernetes clusters a couple of times, right, because of some misconfiguration changes on the underlying infrastructure. And thankfully, due to GitOps, where every single configuration was stored in Git, they could redeploy all their clusters in under 2 hours, right? Those were like five or six different clusters that they had to redeploy, and redeploying them using GitOps and ClusterAPI under 2 hours, they managed to get everything all done, right? So the whole idea is to get declarative infrastructure with the whole concept of infrastructure as code. And infrastructure as code, typically you think of it like Terraform, you think of it like Ansible, right? However, those are not Kubernetes native methods of provisioning infrastructure. So with ClusterAPI is where you get a Kubernetes native method of providing and deploying infrastructure across any cloud provider, Nutanix included. Okay, and because we use Git, we have the ability to track all the changes within Git itself. So whenever I want to make any form of declarative changes, all I need to do is to make the change, commit, create a pull request, and the platform team can then validate the particular request. And if it's approved, it gets merged into the main branch. That way, we get a way to actually track all the different changes and who has made the particular changes and why, right? Giving us the whole chain of decisions why a particular change was made. We also have the ability to do things like runtime customization. For example, we can modify a cluster's configuration dynamically, altering the template in a certain way that it provides customized deployment methodologies for that particular use case while not having to change the base template. And we do this via what we call customize. So it's kubectl customize. We use the same customization, but for the cluster class templates, right? And lifecycle management is much simpler with things like ClusterAPI. All we need to do is to change the version within the cluster class, and automatically all the clusters which references the same cluster class gets upgraded to the next particular version of Kubernetes that is specified. So ClusterAPI is not a Nutanix product, okay? It was not built by Nutanix, but Nutanix contributes to ClusterAPI. So for those who are not aware, ClusterAPI is a special interest group, SIG, right? For infrastructure within the Kubernetes, the CNCF Kubernetes working group, okay? The whole idea is to use Kubernetes native, Kubernetes style APIs to manage infrastructure, okay? So you could have a ClusterAPI provider for AWS, a ClusterAPI provider for Google, ClusterAPI provider for Azure, ClusterAPI provider for Nutanix. And all the APIs from a manifest standpoint is standardized. It is just the underlying workings that the individual providers do to interface with the underlying cloud providers. Okay, it's declarative and provides a consistent definition of clusters across any provider. That's the whole idea of ClusterAPI. Okay. So like I mentioned, there are a lot of ClusterAPI providers. If I'm not wrong, there's something like close to 20 or 30 ClusterAPI providers. And the whole idea is to provide the same consistent experience when managing infrastructure. So some of the popular ones are CAPX, which is Nutanix, CAPA, which is AWS, CAPZ, which is Azure, and some of the very common ClusterAPI custom resource definitions will be things like cluster, machines, machine sets, as well as machine deployments. All of these are essentially custom resources that you use in order to deploy a Kubernetes cluster. Okay, so with a traditional cluster API, right? So cluster API itself is very powerful, but the special interest group recently came out with a new change, and that is the power of, and that is called cluster class. So if traditional cluster API, right, what you need to do is you need to specify things like kubeadm control plane. That specifies a control plane configuration and how it deploys a control plane. This is not even talking about infrastructure yet, right? Infrastructure could be deployed via Terraform. Infrastructure could be deployed via the cluster API providers, okay? So we've got, kubeadm control plane, machine deployment templates, individual configurations. All of these are very repetitive, very hard to read, very hard to configure. And once you configure it once, many times you need to make changes in order to replicate the same particular template. So with cluster class, what we have the ability to do is to create a templating mechanism, right? That allows us to define it once and then reuse it every single place, right? And it incorporates all the configuration requirements of the underlying infrastructure, as well as control plane infrastructure and whatnot, right? So it is topology managed. And what we do from a topology perspective, what that essentially means is that I've got a topology of X amount of control plane nodes and X amount of worker nodes based off that cluster class, and it automatically deploys it. So later we'll take a look at it from a demo perspective, what that's going to look like. So some of the key benefits, right? Single source of truth. You now have got one single template that holds the configuration of all of your various Kubernetes configurations. Okay. The next one is provisioning. With the ability to with the ability to reuse some of the configurations that we have already specified, we can essentially just rubber stamp out multiple Kubernetes clusters as and when your developers require. And I have heard of very interesting use cases. Can't share too much, right? It's a bit of a sensitive topic, but essentially what it does is that it spins up Kubernetes clusters, performs a set of tasks, very large scale, right? Then after that, spins down the Kubernetes cluster, and they use it for things like it could be scraping, for example, right? So there's a lot of different types of use cases, and cluster class allows them to stamp out classes very, very quickly. So it could be a task that is going to be executed in Europe, right? And once that is done, it spins down the Kubernetes cluster, deploys a new set of Kubernetes clusters, perform a different task in the US. So with cluster class, you have the ability to do that very, very easily, quickly. Variables and patches allows us to customize the cluster depending on what configurations they require without having to change the base cluster class. So we do that via the use of customizations. We've got a version control whereby if you check everything into Git, you can very easily roll back or track changes as it happens. Topology management also allows us to again specify things like node pools or machine deployments. Okay. So YAML, I'm sure all of us love YAML because we are all looking at Kubernetes on a day-to-day basis, right? But this is really what it looks like from a cluster class perspective, right? So what we are specifying over here is we are creating what we call a cluster class. This is essentially the template that we're talking about, right? So within the cluster class, we specify which is the control plane template that we're going to be using, what is the machine infrastructure that we're going to be using. And this one is pointing to a Nutanix machine template, right? There is also an AWS machine template, an Azure machine template. For this particular example, is using the one from Nutanix. Then the Nutanix cluster template and what is the machine deployment that I'm going to use. And from a bootstrap standpoint, what kind of configurations do I want to consume, all right? So this is defined once. And you can very easily spin out clusters based on this definition. So over here, I have already defined the cluster class previously. I can thus specify another manifest called kind of cluster. What's my CIDR block that I want to use for my pods or my services, right? What is the topology? And what is the class that I'm going to be using to rubber stamp out that cluster over and over and over again? And what it's going to do under the hood is ClusterAPI will just take all of this information and spin up clusters. So we still have a problem, right? Cluster class is very good for consistency because now you have got one cluster class and that you use to deploy multiple different clusters, right? But sometimes you require some form of dynamic customization. For example, after you deploy a particular cluster, you need to make some changes in the underlying CNI, for example. Or if you want to go and do things like deploying of a container storage interface or a cozy driver, right? We need some form of customization depending on the needs of the particular cluster. So from a Nutanix standpoint, and this is not only a pattern that Nutanix follows, right? There are also other providers that follow the same patterns. But what we do have is what we call ClusterAPI runtime extensions for Nutanix. There's a ClusterAPI runtime extension for AWS, Azure, GCP, and whatnot as well, right? And this is a framework for runtime customization. So it could be pre-upgrade hooks, it could be post-upgrade hooks, right? Or it could be mutation hooks to make changes of the cluster class that is being applied so that whatever changes get applied comes with the changes that is required or customizations that is required. And the whole idea is you don't need to change the base cluster class template. Okay. So from a reconciliation standpoint, this is what it looks like. From an API server, when we do a reconcile of a particular event, right? What happens, we request for a reconcile of a particular event. What happens is that we get the current cluster's topology, right? And we do that via the cluster topology controller, right? Then once we have that, then we compute the desired state that we are trying to achieve. And once we compute the desired state, we loop through a list of patches that is required in order to meet the particular outcome that we want from a declarative standpoint. Okay. So there's a list of patches as well as other patches that is external to the cluster itself. So some of the very common lifecycle hooks that is implemented in ClusterAPI or Karen, right, will be things like lifecycle events. So when when a user creates a cluster, right, sometimes you might need a before create cluster hook, and this hook allows you to make API calls or make changes so that we can get additional info before we actually create the cluster in the first place, right? So this is pre-creation hooks, right? Then after that, the cluster infrastructure is created, control plane is created, and then the API server is available, right? Now, after an API server is available, we might need then to start to send information to external third-party databases, for example. So this is where we can do an after control plane initialize hook, right? That will allow us to send that kind of particular information or get additional information. So when a user upgrades a cluster, right, we can do things like before cluster upgrade hooks as well that allows us to send or configure things. Once control plane is upgraded, we can then call an after control plane upgrade hook. After the workers are upgraded, we can call an after cluster upgrade hook. And lastly, if a cluster deletes, if a user deletes a cluster, we can then do a before cluster delete hook and an after cluster delete hook as well, right? The whole idea is for us to customize and get and push various information depending on the requirements of the particular cluster or the particular use case. Okay, so the key takeaway is ClusterAPI is declarative cluster lifecycle management. Cluster class is a template or a blueprint for consistent cluster deployments. Karen allows for flexibility in customization. And the whole idea is to provide, end of the day, to provide an adaptable Kubernetes deployment and customizations, standardized yet adaptable Kubernetes deployments. Okay. So let's take a look at how a cluster gets deployed using cluster class. Over here, I have got multiple Kubernetes clusters. This is one of the demo clusters I'm currently working on, right? And in my cluster, in my current environment, I have got 2 clusters. They have already been deployed by ClusterAPI. Now, what that looks like from a manifest standpoint is I have a Flux CD that is running under the hood, and it points to my cluster, my GitLab repository, and it constantly reconciles changes. Say, for example, I have got cluster CSIT workload 1, CSIT workload 2, and it's both CSIT workload 1 and workload 2 over here, right? So if I were to go into the cluster resource, this is the entire manifest that I use in order to deploy the cluster, right? So we specify a couple of secrets in order to to interact with the underlying cluster. We have got a cluster resource over here, and this is the cluster class. It references the cluster class that we created earlier. So the cluster class defines the kubeadm control plane, the machine deployment and whatnot. Okay. And then this is where we specify the cluster class. So this is a custom cluster class that we created in Nutanix, but it uses the underlying ClusterAPI references as well. Okay. So over here, I've already created 2 clusters, which is workload 1 and workload 2. Let's say, for example, I want to create 2 more clusters, right? All I need to do is just to copy and paste that particular folder, make some changes to the IP addresses and whatnot. And if I were to commit the changes, deploy cluster 3 and cluster 4 and push. Under the hood, what's going to happen is going to reconcile. And if you take a look at the UI in a couple of seconds, what we'll see is cluster 3 and cluster 4 gets deployed, and the underlying machines under the hood also gets deployed. There we go. Right? So we see workload 3, workload 4 getting deployed. And if I were to look in my Kubernetes cluster, we see the machines under the hood also getting deployed, right? So this makes it very repeatable. All I need to do is just copy and paste or reference the old previous cluster class, change any of the configurations, and then we can get it deployed. Okay. So after your cluster is up, what about applications and some of the day 2 operations? So day 2 operations might consist of things like enabling auto-scaling capabilities. It might consist of things like scaling the amount of worker nodes that you need, right? So what we can do is use things like GitOps in order to make those kind of changes. So what I can do is, as a platform engineer or a platform operations team, I can make some changes to increase the replica count of my worker nodes or increase the replica count of my deployments, right? Then the platform engineering team can check to see whether they are happy with the changes before they actually merge it into the main branch, right? So let's take a look at what that looks like. In my Git repo, I specified the number of clusters of worker nodes that I want, right? So I see that the number of my autoscaler, the minimum group size as well as the maximum group size. Let's say, for example, I wanted to scale this particular worker node from this particular node pool from 4 to maximum to a minimum of 8 and a maximum of 10, so that I get some auto scaling capabilities. I can just change cluster 1 min nodes and max nodes. Commit it and change, and what we'll see in the background is a new set of worker nodes getting deployed, right? I can also change things like CPU, memory, or even create an additional node pool, and what's going to happen is going to reconcile in a stateful manner. Now, if, for example, whatever, say my underlying infrastructure gets destroyed because of some ransomware or whatever, right? I don't have to worry about any of the configuration losses because everything is all stored within Git itself. All I need to do is just to reapply the configurations and you will just deploy the classes all over again. Okay, so we see workload cluster 1 spinning up 4 more new workloads, 4 more new nodes, and after a while, we will be able to see them join the cluster and be in a ready state. Okay. Okay, so some of the key components that we use under the hood, right, is things like Flux CD, Helm. This one I don't need to mention too much. Customize for us to do patching. Istio for things like multi-cluster management. We also have shipped Cilium together with Cilium cluster mesh. This allows us to deploy an application across multiple data centers, right, and have them all be able to communicate with each other out of the box. Right. And lastly, we've got ESO, which is external secret operator, which allows us to do secret synchronization as well as management. So essentially what it allows us to do is that it allows us to communicate with things like HashiCorp's Vault, AWS secret store and whatnot, and pull the secrets so that you don't have to actually specify them within manifest itself. Okay, so Flux under the hood is made up of a couple of key components. When we bootstrap Flux, which is done out of the box by Nutanix, but underlying, you can do a Flux bootstrap, and that will call the Kubernetes API, which will then deploy the source controller as well as a customized controller. So the customized controller looks for customization manifests and apply them. The source controller connects with Git, it connects with S3, it connects with multiple sources to get the source of truth. Right, and then it constantly performs the reconciliation using the Flux call. Okay, so source controller watches the different repositories. Then if there are any changes, it pushes it into the Helm controller. Then from a Helm controller, it then performs new releases, alerts, policies, and whatnot. Okay, and then it deploys all the various components. So there's also a customized controller that based on the source controller and what's within the repository pushes out additional information and performs the customization before it applies the changes to the different clusters. Customize Kubernetes native way of configuration management. It's purely declarative and is based on the base as well as overlay architecture methodologies, right? So you have got a base which stores a set of configurations, and if you want to make any changes for different set of tenants or different sets of clusters, you can then put in additional overlays whereby we merge and flatten the changes. And lastly, external secret operator, which allows us to push changes into various namespaces or push secrets into various namespaces and whatnot. Okay, so I just want to take 5 minutes to share a little bit about Nutanix Kubernetes platform. I know Nutanix has historically not been well known in the cloud native space, right? So we recently acquired a company called Day2IQ, and Day2IQ has had a Kubernetes cluster for the past Kubernetes distribution for the past 7 years, right? And they called it DKP. So we acquired them early last year, and we rebranded their platform into Nutanix Kubernetes platform. And we have seen a huge uptick and a number of clusters of customers who are reaching out to us to understand what NKP is, and they really love the product. They love the product because of two key reasons. The first one is it's a complete platform. It is an open platform. So what does complete mean? When you run Kubernetes in production, you don't just use Kubernetes. You need monitoring, you need logging, you need a service mesh, you need cluster mesh capabilities, you need to have some form of storage, you need a container registry, you need disaster recovery and backup for your applications. This is where Nutanix Kubernetes platform provides a complete solution that is based off CNCF upstream best of breed solutions. So NKP is not some super special distribution that is only unique to NKP. Any one of us can build our own NKP. It is just whether we want to spend the engineering effort to troubleshoot and to maintain the life cycle of it. So where Nutanix shines is we take the best of breed, combine everything together, integrate everything together, and deliver it to our customers. The next topic is open. And Nutanix Kubernetes platform is an open distribution. Zero proprietary APIs, everything based on upstream, right? This allows our customers to move into NKP and move out of NKP in a very seamless and easy manner. Zero lock-in, zero proprietary APIs. In fact, it's going to be easier for you to troubleshoot NKP compared to any other distribution which has got proprietary APIs, because it's likely that someone who has already worked with vanilla Kubernetes already has encountered a particular issue before. Okay. Yeah, so this is something that I'm very proud of. Worked with the team for close about a year, and I think this is one of the fastest deployments that ever went into production before. So this is public news, right? It's all over LinkedIn. It's not something that I'm I'm sharing that is confidential, right? But it's something that I'm very proud of, and I'm very glad to have one of the participants of the team over here as well to share if he wants to share about anything that NKP can provide to the team, right? So in summary, it's open source foundation, 100% graduated CNCF projects, no vendor lock-in, no proprietary APIs, enterprise-grade reliability, enterprise-grade security. GitOps maturity, everything in NKP is powered via GitOps. We do not use any other form of methodology, right? We use ClusterAPI under the hood, so this allows us to deploy across any infrastructure of your choice. And it's all about operational efficiency and security, right? For multi-cluster management, as well as zero secrets stored in Git. Okay, so with that, I'd like to thank you all for your time, and I'd like to see if there are any questions.
The deployment what you're doing, does it follow bare metal or is it a VM when you're deploying the cluster?
Very good.
Specifying the cluster class, maximum workloads and all.
Yes.
How they fix up.
Very good. So Nutanix, okay, let me first repeat your question so that the guys on the Zoom can hear, right? So the question is, where are we deploying the Nutanix, the Kubernetes clusters on? Are they running as bare metal or are they running as virtual machines, right? And if they're running as bare metal, how do we pick up the changes? If it's running on virtual machines, how do we reconcile what is running in a virtual machine? So ClusterAPI allows us to hook in with any infrastructure provider, and most infrastructure providers today are all virtualized. Okay, you have got AWS virtualized, Azure virtualized, Huawei Cloud virtualized, Nutanix virtualized, right? So we hook in with ClusterAPI to the different hypervisors and then call the necessary APIs to reconcile any changes as well as to deploy any virtual machines. Now, bare metal is an interesting one because historically there's only one vendor in the world that could do bare metal, and that is Canonical, right? With MEAS, M-A-A-S, Metal as a Service, right? D2iQ also has a ClusterAPI provider for bare metal. We call that ClusterAPI provider pre-provisioned. What this means is that a developer or a cloud infrastructure engineer deploys the bare metal server with, say, for example, Ubuntu or RHEL or SUSE or whatever infrastructure OS that you want. We take the IP address and then we run kubeadm to bootstrap all the bare metal servers to to a Kubernetes cluster. So this is how NKP or Nutanix allows us to deploy across bare metal, cloud, AWS, Azure, GCP, Nutanix, VMware, so on and so forth. You just use the power of ClusterAPI. I hope that answered the question. Thank you. Any more questions? Very good.
It's the recommended way to create the cluster on.
Is the recommended way to create a cluster on NKP? I just write the cluster class YAML and the cluster YAML, and then I assume there's a button I can just upload the YAML file.
Yeah, good question. So the cluster class has already been created with NKP. The cluster class has already been created for you. So there's no need for you to create a new cluster class. But what you could do is to take that cluster class that we created for you and make modifications to it, if that is what you need. And then once that is done, you just create a new cluster resource referencing the modified cluster class, and you'll reconcile the changes and deploy the cluster for you. That is number one. Number two, for example, you already have got a cluster that is deployed, and now you want to effect changes throughout your entire fleet. You clone that original cluster class template, make changes to the cluster class template, and you configure the clusters to reference the new cluster class template. That will roll out the changes across the board.
The steps to do this, is it in the NKP documentation?
It's in ClusterAPI documentation.
Oh.
Yeah, because a lot of this is all upstream. I mean, like I mentioned, right, Nutanix Kubernetes platform is not some super unique, super how do I put it? Modified version of Kubernetes. It's all upstream. So a lot of things, right? It's impossible for us to keep all the upstream documentation in the NKP documentation. So a lot of times we reach out to see which, like for example, ClusterAPI, go to the ClusterAPI book. That would be the best way to get all this information.
Okay, thank you.
Thank you. Thanks for the questions. Any more? Yes.
Let's say you are So let's say you're doing a deployment of a cluster in the middle of runtime, it failed. How do you completely roll back rather than redeploy from the point it failed, so that you have a cleanup, and then you get those logs, analyze the issue, and then you fix it, and then
Fix it
and
fail forward.
Yeah.
So it's really about failing forward rather than failing back.
So it's not like complete rollback.
No.
So
So actually what you could do, okay, when you do version upgrades, right, that one is a bit more, that is more of failing forward. But then if you're making changes in your cluster class and you don't like the changes, you can always revert the changes by using, if it's checked into Git, revert the changes in Git.
Yeah, no. It's an initial deployment of cluster, or what I'm going to say is cluster creation.
Right.
By creating the cluster itself, it failed for whatever reason. Now, instead of failing forward, I'm going to say troubleshoot and then continue forward.
Yes.
Like usually how the Terraforms and all those does. But how do we clean up those the templates of these cloud formations and all does, complete rollback and redeploy?
Very good question.
So how is it does? Yeah.
Yeah. So everything, let's say, for example, there is a deployment that fails, right? And we have already created what we call machines. Machines is typically virtual machines or bare metal machines, right? What we can do is we can just go into kubectl or K9s, view the machines that has been created, right? And see what is the issue that is causing the creation to fail. It could be out of IP addresses, it could be out of resources, it could be a wrong subnet name, right? We can make the changes over there and commit it back into the cluster class or the cluster definition, so that it catches that changes and redeploys a new set of machines. Yeah. Does it answer your question?
Yeah, so it's not like a complete rollback. You fix it and then
move forward. Yes. Oh well, I mean, if you have a template that is checked in, right, and it fails to deploy, right, you can kubectl delete everything within that set of manifests, right? For example, if I wanted to delete a cluster right now, right, I can just remove this customization away, delete cluster 4, and what's going to do is going to pick up those changes and delete the cluster away, regardless whether it's a failed deployment or a successful deployment. And then what I can do is is this particular, essentially what's happening is taking this entire set of manifests and does deleting everything. Then ClusterAPI does reconciles under the hood. What resources to delete? Yes.
So when you're, let's say if you're deleting a cluster, which is already in use, and there are a lot of PVC secrets and everything's are there, so does it still go ahead and delete it, or it just warns and
It's declarative. So somebody knows that I want to delete it. So somebody, like for example, if I'm the platform engineer, right, and my colleague over there, Washon, wants to delete the cluster, he's going to do the exact same thing that I just did, and is going to try to commit and merge, right? Then he will create a pull request, which I have to review.
understand? I mean, agree with the pull request and all. Sometimes people don't even go through those codes and they just approve.
Commit.
So that's the thing. But if you're deleting a cluster without even having a cleanup process of like, first remove your secrets, or remove your what you call your PVCs and all those stuffs, then config maps as a process, then delete your deployments, like go step by step, removing your worker nodes kind of a things. And if you directly go delete a cluster, you lose everything, right?
Yes, you will lose everything.
So you had mentioned that under 2 hours, actually, we can restore a cluster, right? So
Yes.
is it possible for like doesn't it vary? So the restoration process doesn't depend on the number of nodes underlying the cluster.
So it does actually. So say for example, it also depends on the infrastructure you're running on, right? Say for example, you're deploying on a virtualized infrastructure, spinning up virtual machines is very quick, right? Under 2 hours, very easy to achieve. But if you're running on bare metal servers, then the challenge becomes a little bit more tricky, because now you have to reformat, you got to reinstall the operating system, then you need to provide IP addresses to cluster class, IP address to ClusterAPI before it does the reinitialization or bootstrap of the individual clusters, right? That depending on the infrastructure provider you're using, varies the number of amount of time taken in order to restore the clusters or redeploy the clusters. We're not really restoring the clusters per se, we are redeploying the clusters.
So in case of a fixed or static infrastructure, that needs it might take a longer time. Actually.
Yeah, correct. But if you have everything, I mean, if there is a ClusterAPI provider for that particular infrastructure, things will go much faster than doing it via Terraform or manual, because it's all native Kubernetes.
Thank you.
Thank you.
Okay, so my understanding is if I create a cluster on NKP, the Cilium agents will be installed on the node directly, right?
Yes.
So, if for example, if let's say I have 10 nodes, the Cilium agent works on 8 of the nodes, then on 2 of the nodes it's not working, then do I complain to Nutanix, or like is it why my node
You will log a case with Nutanix, yes, there's one, but
okay.
So there is things like machine health checks that if, let's say for example, if your Cilium agent is not ready and it's
Yes.
crash looping for whatever reason, the machine health check will detect that it's not healthy, and then it will report to ClusterAPI. And what ClusterAPI is going to do is going to delete that particular node that is not healthy, and then redeploy a new one.
Oh, okay. So when I run my cluster on NKP, right, what is Nutanix responsible for, and what am I responsible for?
Basically you call Nutanix first. You let Nutanix do the triage.
Oh,
Yeah.
okay.
Nutanix will do the triage. Then if it's a bug or it's an integration issue that we did, that we introduced, we will fix it, right? But if it's a deployment that you deployed and there are some issues and the pods are crash looping for whatever reason, we will still take a look.
Okay.
We'll try to help you fix it. If we can't, then we're going to revert it back to you.
Okay. Okay, so in this example, let's say is the cluster was created by Nutanix and the Cilium agent was also installed by you guys. Then if I realize it's something wrong, then
it'll be Nutanix. Call Nutanix.
It's free, right? Like
if you're already a Nutanix customer, then yes, you are entitled to the support.
Okay, Ken, thank you.
Good. Question at the back.
Pricing model for the Kubernetes distribution?
Pricing model for the Kubernetes distribution. We charge by virtual cores, virtual CPUs, or physical cores for worker nodes. vCPU or physical CPU, depending on your deployment model. If you're deploying as bare metal, then worker node bare metal CPUs. If you're deploying as virtualized, then worker node virtualized CPU. And if you are already a Nutanix customer, then of course we have got a buffet style as well, where you can just deploy as many as you want. So the meter is virtual CPUs or physical CPUs, basically cores.
If you got a Nutanix, if you got a okay. So you're saying if you're a Nutanix customer, then what? There's a cost to it. Like how much? You say buffet style?
Yeah, so if you're a Nutanix customer, you can deploy Nutanix Kubernetes platform, the starter edition, for free, and you still get support. If you're a Nutanix customer and you want to get additional features like GitOps or platform applications, you can upgrade to NKP Pro or Ultimate, right? And that gives you what we call a full stack licensing. And that will allow you to deploy unlimited amount of Kubernetes clusters with unlimited amount of worker nodes.
Okay, yeah, understood.
Thank you.
If I want to just to play around for my own exploration, I can do it for free.
So you can use, in fact, my lab, this lab that I have right now, that you see me running all of this stuff, is using this thing called Community Edition. So I run, so I have a small little data center at home. Then I run Community Edition, which is basically the non-supported version of Nutanix that is running there. Then I install NKP on top of it. It's free. That's free. But you can't call Nutanix for support because it's free.
Thanks.
I mean, you can always post the questions, the issues on our community page lah. Good questions. Thank you all very much. I didn't expect that many questions. Appreciate it. All right. Thank you. Right. Next up, I'd like to invite Vivian, right, to share on AI inferencing at the edge. Thank you. You want to hook up? Easier.
Oh, I want to use that.
You sure? You need the microphone? Okay.
You need to stop your share.
Yeah.
Good evening, everyone. Before I start my talk, I want to introduce myself first. So I'm Vivian Hu, and I'm a CNCF Ambassador. I'm from the CNCF WasMagic project. So WebAssembly is a very new technology. Right now, our project WasMagic is in CNCF Sandbox. So today I want to share how we use WASM to build efficient, portable inference applications on the cloud or the edge cloud. So I will start with a story of our customers. So customer is called Phillipines. It's a local marketplace app in the US. So you can buy and sell secondhand items. And in 2017, the CTO of Phillipines has a problem. So can they add the title for the stuff that user uploaded automatically? So for example, if I upload an image, if I want to sell my laptop on Phillipines, can Phillipines, the platform, provide the title and the description of my second-hand laptop? So the answer at that time, at 2017, is no. But right now we are in 2025. And I think as the development of large language models, the answer right now is yes, and we can do more. Let's say if I upload a video that's introducing my laptop, so we can have a video transcription by the whisper model. And if I upload an image, we can use the vision model, the VLM, to recognize the image and provide the title and the description of the image of my laptop. And we can also, because it's a peer-to-peer market, so there may be some bad guys. They will spam the real user, and we also can use the large language model to do text summarization and sentiment analysis to detect if this one is a good user or it's a spam. So this is a very very simple example. So I just took a photo of my monitor, and then I send this image to the Gemma 3.4b model. It's a vision model. It can recognize the object in your image. So the prompt is very simple. I just said, please recognize the object of the image and generate a description and title for the e-commerce platform. And then this is a result from the Gemma 3.4b model. We can see it's really nice. And so with this simple examples, we can see that we can use large language models in their e-commerce workflow. So there are I think there are three sides. One is the video. Like I just said, if I record a video and introduce my laptop in that video, when you upload the video to FileMails, it will use the whisper model to transcribe the video. And it will, the output is the summarization of the for the video. So the recommendation engine will know what this video is about, and it will send send this video to other people who are searching a laptop or something like that. And it can also generate video description, because I upload video and I introduce it. And another one is the image. So when you upload an image to the FileMails platform, it will use the vision model to understand the image, and the vision model will generate a title and a detailed description of the image. So it will be done automatically by machine, not by the real seller. It will simplify the onboarding process. So in this workflow, the image model can also help improve the recommendation engine, because if we want the recommendation engine works better, we need to know what people are talking, what people are selling on their account. And then then it can generate title and descriptions. So another side is security. So like I mentioned before, you can use the large language model to analyze the sentiment of the conversation. So we can detect if the DM is fried or not. So if the AI detects this user is fried, it will remind the user that the other party may be a scam or fraud. It will reduce the risk of the real users. So this is the AI in FileMails. Because in my title, I saw that portable and efficient inference in cloud, which means that we are not using OpenAI. So why we just not use OpenAI? Because there are 4 reasons. So I think the most important reason is that OpenAI is expensive. So there will be 70,000. There will be let me think. There will be 20,000 videos in 5 miles per day. So if we use OpenAI to do transcription and summarization, it will be 900 per day. It's very expensive. But if we rent a GPU machine from AWS or Nutanix, it will be cheaper. So for those tasks, two NVIDIA T4 machine are enough. So if we self-host the large language model, it will be cheaper. And the 3 other reasons. First one is the OpenAI is one size fits all model. So it's like a optimization for the specific language, like Spanish. And the other, secondly, OpenAI lacks privacy and compliance. Not everyone wants to send their data to OpenAI's data center. And the last one is that OpenAI and Germany has a rate limit. Because 5 miles has a very active user group, so it can't be used in the production environment. But I think the most important is OpenAI is expensive. So we don't use OpenAI. We use the open source AI because the open source AI has catch up with the closed source OpenAI. So with I think the new the latest models from the KSUG team, the performance is can beat OpenAI and Germany 2.5. So we use OpenAI because OpenAI is good enough, not only because we don't want to use closed source OpenAI or closed source AI. So the next question is that we choose open source AI. We don't use closed source AI like OpenAI. So how can we do the inference? So the answer from our side is that the Python we don't like Python. We don't like C++, because the Python is too heavy. And there are lots of complex dependencies. You need to handle Python environments very carefully. And the second reason is C++ is not cross-device portable. But with Wasm, Wasm is the one runtime to run all AI models on any hardware. So I will explain it later. By the way, this is our open source project. You can check it on our GitHub. So why we use WebAssembly? There are 4 reasons. So the first one is that Wasm is very lightweight. The WasmIG runtime and the API server for inferencing is less than 30 megabytes. It's very, very small. And there are no external dependency. There are no Python packages. All you need to do is to install the Wasm runtime, to download the API server, to download the model, then you can run it. I will do a quick demo later. And the second reason is Wasm is high performance. So there is no code start time in Wasm. And unlike Docker, and more importantly, Wasm can automatically use the device, local hardware, and software as solution. So if we running on WasmIG on a CUDA machine, it will use the CUDA to accelerate your inference. Just thirdly, WasmIG supports multiple type of models. We support large language models. We support the text-to-voice model, speech-to-text model, text-to-speech model, image generation, and vision models. So you can use one runtime WasmIG to run all the models. And lastly, but I think it's very important, WasmIG is portable. So for example, if I compile my program into Wasm in this MacBook, you can run this Wasm binary in your CUDA machine without any changes, because Wasm is cross-platform, and it supports lots of hardwares like NVIDIA, Mac, AMD, and Ascent. So with Wasm, I think you can run it once and run it anywhere. So it will simplify the workflow of DevOps. So for devs, you only all you need to do is firstly compile the source code to Wasm. And then in this, when you're writing the source code, you don't need to worry about the GPU drivers or tensor libraries. You only need to call the WasmMagic API to perform inference operations, because WasmMagic already has those platform APIs. It's cross platforms, and then you distribute and deploy the Wasm binary using the existing tools like Kubernetes, because WasmMagic is a CNCF project. So we also have integration with Kubernetes and Docker. So for the ops, when you get the Wasm binary, you only need to install WasmMagic with the LM plugins, and the WasmMagic will install the GPU driver and GPU driver for the device, and then you need to do is to run the Wasm binary on your on the CUDA driver or something like that. You don't need to build images, Docker images for each platform. And one bonus is that WasmMagic itself is a security sandbox, so it can isolate the program of your from your hardware. And it can also be managed by container tools like Kubernetes, Docker, and OpenShift. So all the tools that you are familiar with. So so I will stop at here, and let's go to check a demo. So okay, it's big enough. So I already downloaded the WasmMagic runtime, so it's just easy to use installer. And another one is that you need to download the model. So we only support the GUF model. It's because WasmMagic plugin is based on llama.cpp, and then you need to download the llama API server.wasm. It's the LM inference. Basically works with any open source like language models. And this is a model name. This is a prompt template, because the different models use different architectures, so the prompt templates will be different. And this is the content size. So like I mentioned before, if you want to use WasmMagic to run a large language model, you only need to install the WasmMagic runtime and the LM plugin, and download the Wasm binary. And the Wasm binary itself is cross-platform. So no matter what hardware you are using, you only need to download this Wasm file, and then download the model. So right now, let's run it. So you can see the model is running on my 8080 port. So let's go to another terminal and ask a simple question. So this is just a simple demo. So I just tell me a joke about Singapore. Because I'm not using the streaming mode, so it will take several seconds to get the full answer. Okay, so we got the joke about Singapore, and my machine is not very low end, so it's only it's M2 chip, and with 16 gigabytes memory, it's not very good for the inference. So it take several seconds. So this is a quick demo, and if you are interested in, you can go to our documentation on the llamaedge.com, and here we have some documentation for running large language models, vision models, embedding models. Embedding is very important for the RAG application, and speech to text model, and text to speech, and also text to image. You only need to download the WasmMagic to run those models. And we also have documentation to use llamaedge in Docker and in Kubernetes. So if you are interested, you can go to this website and check more. check out more. So let's go back to my slides. So it's so this is the architecture of the IOM application for 5 miles I mentioned earlier. So this is the 5 miles platform, and for this task, we celebrate the tasks. So for the Redis queue and the video process task, we run it on a CPU machine, and we also have another GPU machine. The GPU machine focuses on running large language models on the GPU machine. So when user uploaded a video on the 5 miles, they will send the video to the server on a CPU machine, and the server we have a Redis queue, and we have applications that processes the video, like extract the audio, cancel the noise, and etc. And then we got the audio file and send it to the IOM application on the GPU machine, and we will have 2 models. One is the Whisper; it will get the caption, and the other one is the Llama 3.18 billion model. It will summarize the video content based on the caption just got from the Whisper, and then we have so we use Wasmagic to host those two models. And we get the caption summarization, and we will send the result back to the application on the server application on the CPU machine. The CPU machine will also detect the language, and finally, the server machine on the CPU, the server application on the CPU machine will return the language, the caption, and some summarization of the video. Then it will be used for the recommendation engine to do better recommendation for users. So my talk is a landing talk, so it will be very quick. So takeaways, we have 4 takeaways. One is that the open source model is good enough for some use cases, especially for the text recognition and the simple summarization. And the open source model is recommended when you need more customization, because you can get the model file, you can fine tune the model. It will be better for the customizations. And Wasmagic is the one runtime that rule all the LLMs. You can use Wasmagic to run large language model, image generation model, text speech, speech to text, and vision models. And you can, if you are using Wasmagic to run large language models, it will be cloud native, because Wasmagic have great integration with Docker, Kubernetes, and OpenShift. So one more thing. So right now I'm doing a very fun project. It's an open source voice AI agent. So it will convert your ESP32 device into a talking machine. So here is a video.
It actually talks back. Hi, could you please introduce yourself?
Hello, darling. It's a pleasure to meet you. I'm Marilyn Monroe, whereas I was born over 10 years.
So I will just stop here. But hello. Oh, okay, I figured it out. So I would so from the simple video, you can I make the so I prompt the large language models to make it act as Marilyn Monroe, and I also clone Marilyn Monroe's voice. So in this video, this ESP32 device is Marilyn Monroe. So I can talk it and ask some questions. So this is our new project. If you are interested, you can go to this website. Okay, that's all my talk, and I know it's very fast, and I'm not sure if you ever heard WebAssembly before. If you didn't heard WebAssembly, I think maybe it's a little difficult for you to understand. But if you don't, please check in our GitHub. So, is there any questions?
Was the edge running bytecode on the virtual machine?
Oh, sorry.
Is it running bytecode? Was the edge running bytecode on the virtual machine?
Bytecode. So, I don't know what is bytecode, but WhatMagic can run on Windows, Mac, Linux, or CPU machine from the cloud platform. No. You don't need oh, sorry. So are you asking compiling the source code to WASM? Oh, so it depends on the language you are using. Right now we are using Rust, but you can also use C++, JavaScript. Or WebAssembly suppose those languages. So WASM itself doesn't have a compiler. It depends on the language compiler. So if the language compiler suppose the WASM 3, the WASM target, you can use the language compiler to compile your source code to WASM, and WASM is just run it. I think GCC target WASM because LLVM supports WASM. Okay, any more questions? If no, thank you.
Okay, I think if there are no more questions, and Yongkang, do you want to close off the session?
Yep. Thanks, Winson. Thanks everybody for joining us. I just pop up this on screen. Actually, did I? Yeah. Can you guys see my screen? So I really hope you guys can win something, take home. Okay. Again, thanks everybody for joining us, and thanks to Nutanix give us the opportunity to hosting our meetup at the Nutanix office. And by the way, the awesome talk from Winson. Yeah. Also, thanks to Vivian for joining us to talk about the WASM, all the cool open source capabilities. Again, thanks everybody. I hope you guys enjoyed the session, and we are looking forward to having you guys join us again in November and December. Both we already confirmed back at Nutanix.
Okay,
Thanks,
Yongkang.
Winston. Back to you.
Thanks, Yongkang. All right, thank you everyone. Appreciate your attendance and spending the time.